Hello again, welcome to Musical Math today. And unfortunately, we're getting near the end of our lessons because our school year is coming to an end. So we're going to keep going right to the end. Going to continue on with chapter 12 today. I'm actually going to do a little combination of lessons 12.8 and 12.9. Okay, I didn't want to do a whole lesson on 12.8 because it's pretty basic. It's just the units of time. We're going to be on page 685. Dealing with the units of time, okay? And once again, we have to measure time, and we've come up with units to do so. The basics, kids, you know your basics. We have 1 minute equals 60 seconds, okay? There are 60 minutes in 1 hour. 1 day equals 24 hours. There are 7 days in a week. There are 12 months in a year. And finally, we have 52 weeks also make up a year. Okay, now when you're talking about months in the year, remember, we count the 12 months. Doesn't matter about the days because every month, not all the months have the same days. Okay, some have 30, some have 31, and we know February 28 or 29, like this year, depending on whether it's a leap year or not. So I'm not going to spend much time on the units of time. You should know them. Don't get confused with the months, but you should be okay. All right, today we're going to move on to the next lesson, 12.9, which I made a model for you. Just give me a second, let me get there. 12.9 is problem solving with what we call elapsed time. Okay, elapsed time is the amount of time that has passed from the beginning of an event to the end of an event. Okay, elapsed time. And our lesson today reads, Dora and her brother Kyle spent 1 hour and 35 minutes doing yard work. Then they stopped for lunch at 1:20 p.m. At what time did they start doing yard work? Okay, and remember, when we talk about AM and PM, AM begins at midnight and ends at 11:59 a.m. Then it becomes noon, which is 12 p.m., and that goes right up until 11:59 p.m. right before the next day starts. Okay, so what we're going to do here is I'm going to draw something that resembles a number line. Okay, it's going to have a start time and an end time, but we're not sure what time we started. Okay, but we did know how much time they spent doing the work and what time it ended. So here's what I did. I made a chart for you. We're going to look at the top model first. Okay, and if you look at the top model, let me get it focused there for you. We have a start time and an end time. Now, we know that they ended at 1:20 p.m. We also know that they spent 1 hour and 35 minutes doing the yard work. So what we do is we make out our timeline. We know we're going to end at 1:20. Okay? You might not know where they started yet. That's what we're going to find out. So what I like to do is I know that they ended at 1:20. They spent 1 hour and 35 minutes doing the work. So I rounded that off to 2 hours. And I have my number lines ending at 1:20. And if I subtract 2 hours from 1:20 p.m., I would start at 11:20 a.m. Okay? Then going back to our end time, we know they spent 1 hour. So we're going to go from 1:20, jump a full hour down to 12:20. Okay? And then we're going to start going back 5 minutes until we hit 35 minutes because they worked 1 hour and 35 minutes. So our hour takes us to 12:20. Then we go 5 minutes to 12:15, 10 minutes to 12:10, and so on until we hit 35 minutes. And if you notice, 35 minutes ends at 11:45. So what time did they begin? They started doing their yard work at 11:45 a.m., okay? And then they finished at 1:20 p.m., and that was 1 hour and 35 minutes of elapsed time. Okay? All right, now I'm going to go on to the next problem, which is on the following page. That page, by the way, kids, in your book was page 691. We're going to go to 692 now and try another problem. This one says, Ben started riding his bike at 10:05 a.m. He stopped 23 minutes later when his friend Robbie asked him to play kickball. At what time did Ben stop riding? Okay, now this problem's a little different because we know when he started. We don't know exactly what time he finished. Okay, so in this case we have a start time, but we're not sure of an end time. Okay, so we know that he started, we said, at 10:05. And we know that he rode the bike for 23 minutes. Let's see what time he finished. All right, let's go back to the board here. Another model, the bottom one this time. Okay. We know our start time, 10:05, okay, a.m. And I made my model go up to about 10:30, okay, because we know he didn't go 30 minutes. So I figured play it safe from 10:05 to 10:30 isn't 30 minutes. So he probably drove less than that. So let's see what we did here. We start at 10:05. Sorry, let me get the right model there for you. Start at 10:05. And we're going to jump up 5 minutes. So we go 5, 10, 15, and then 20 minutes lands us at 10:25. But we know he drove 23 minutes. So if we continue on, we're going to go 3 more minutes from 10:25 to 10:26, 10:27, and then we're going to end on 10:28, and that is going to be his end time. So the answer is, if he started at 10:05, rode for 23 minutes, he would finish at 10:28. And that's another way you can do elapsed time. In this case, we knew the start time. We knew how long he rode, but we didn't know what time he finished. These little number lines can help you out. Now, as you get better at this, you're not going to need the number lines, okay? You're going to learn to do it in your head. All right, but for now, a good way to start, use these little elapsed time models, and they should make this a little bit easier for you. Okay? Have a good one.